Okay, Shane, would you like to make instructions?
Good morning. Thank you everyone for coming along and watching this wonderful video and this seminar that we've invited you along to. What we're going to do is obviously, as you can see, it's being recorded live, but obviously if we have questions open to you shortly afterwards. If you do have any questions, obviously call me, email me, and we can obviously come back to you later on down the line. But what we obviously want to do today is obviously go through this seminar, go through this presentation with all from Freedom Hygiene that we're working with. We're part of obviously a nationwide group, and he obviously working with obviously other nationwide members regarding products that he offering. So we are obviously just using him obviously as a person we can contact and work with to try and offer the new Freedom Hygiene products to obviously help you in the brewing industry. So if you do again have any questions, please give a call to me or email me, we can go through them. Obviously, I'll pass you over to Paul, and he'll get obviously discuss and tell you about what we're doing and go from there.
Thank you, Shane. Share the screen 12, so video on, but maybe just wanted to introduce yourself a bit. Yes, I will. Thanks. Yeah. Right. Well, thanks, Shane, for the introduction. I'm really pleased to be here to talk to you about brewers because it's something that I have a passion for. I think it's back in the late 1970s when I had my first job with Diversity, which lasted 17 years, and that was working initially in their brewing division. So for many, many reasons, some good and some not so good, I got a taste for the industry in more ways than one. But what I want to share with you this morning for half an hour is something which not every brewer is aware of. And when I say every brewer, I'm also talking about the global brewers, the AB InBevs of this world, the molten cores of this world, the traditional family brewers that we have here still in the UK, and all of you, I don't call you micro brewers, but next generation brewers, I think is a much better phrase to use because it infers that you're going to be here for a long, long time. And the selection and the tastes that we're getting now from all those brewers working out throughout the UK give us such a wide variety of choice that it's unbelievably good. I want to talk to you about biofilms because it's only been recognised in the last 10 or 20 years that both in food manufacturing and in the brewing industry, biofilms are going to be present. And I just want to share this paper with you, which is on the first slide. There it is. Now, I picked this up quite recently. It was a very interesting research article that was printed in the Journal of the Institute of Brewing back in 2019. And I've highlighted the points that I wish to share with you on the right-hand side. So this is a transcript from this particular research article. And it talks about Lactobacillus brevis. And I call that a force to be reckoned with because it's the most significant beer spoilers bacteria worldwide. And you can find it in all stages of brewing, from primary and secondary fermentation through to conditioning, bright beer storage, filtration, and the packaging process, whether that's a bottling line or indeed a canning line or a cask line. There are a large number of Lactobacillus brevis strains that can form biofilms. It can produce its own biofilm, but it can also colonize biofilms provided by the species. And now this is the important bit that I've highlighted in red. What makes biofilms so dangerous for any hygienic production in the brewery is that they provide protection against various environmental stress factors, such as cleaning chemicals and disinfectants. So this is the reason that we want to share this with you. Conventional chemistry, the caustic detergents that you use, the nitric phosphate blends that you use, peracetic acid and hypochlorite and so on, are all necessary for hygienically cleaning a brewery, but none of those cleaning chemicals will remove a biofilm.
And so we have to look at alternative methods. First of all, we've got to determine how we can find biofilms because they're visible. And then once we've found them, what is the most effective way of eliminating them so that we don't have a threat of beer spoilage from beer spoilage organisms which are being protected within that environment. Excuse me. So looking at gram-positive bacteria, lactobacillus, it doesn't mention the one that we've just been talking about here, Lactobacillus brevis, but talks about others. And then we've got Pasteuranus, which is a lactobacillus which produces rope in beer. That's what it's commonly called as. I'm sure that you may have seen this, hopefully not in your own products, but certainly in photographs. And this appears as strands of biofilm floating in cascade, and that's produced by particular lactobacillus species, which can produce biofilms. And on the next slide, we can see another source of beer spoilage from Pediococcus, and one strain there can produce rope, turbidity, acidity, and that horrible diacetyl or butterscotch teardrop kind of flavour that we got from detecting beer. Moving on to the next one, here we have gram-negative bacteria. I'm sure we're all familiar with acetic acid bacteria. These are used deliberately in the production of malt vinegar. So malt vinegar is simply work that has been allowed to acetify, deliberately putting acetic acid bacteria into the raw work. But if you go to the bottom, and we see that certain strains can grow in beer in presence of very limited supplies of oxygen. So we've got a CO2 atmosphere, that doesn't bother them. They can produce large quantities of rope or large quantities of biofilm. Zymomonas, certainly in my diversity days, this is something we came across when working in cask production and cask filling. It's not actually reported as producing rope or biofilm, but what we do know is that those beer spoilage organisms, such as Z or Zymomonas, whilst it won't produce its own biofilm, it will inhabit the biofilm of other species. And that's important to remember. It's the same within the food industry. Certain foodborne pathogens will not produce vast amounts of biofilm. So they'll find another bacterium that will do that, and they will live, they will cohabit within that biofilm with bacteria of different species. Saccharomyces, I don't think it mentions rope in there, but we do know that Saccharomyces will create biofilms, and those that don't will inhabit biofilms. So the question is why biofilms are difficult to control. Bacteria entering naturally, we've got raw food there, but the materials that are coming into the brewing process are food materials. So they'll be coming in with the raw ingredients. People, we walk into the brewery every day, we walk in from the outside, the yard, the pavement, the road, the car park will have been covered in biofilms, so we're bringing those biofilms on our feet. And that's just a statement of fact, nothing to get too worried about at all. The second point is they grow very fast, within minutes. They can grow in areas of difficult access and have the capacity to spread. And I'll tell you more about that in subsequent slides when we look at some photographs of where we're going to find biofilms in the brewery. They're invisible, so we want a tool which makes them visible within seconds so we can find out where they are. And the last 2 points are perhaps the most important. Biofilms are resistant to conventional chemical treatments. When I was first told this back in 2016, it would be wrong to say that I didn't believe it because the information came from a very good source. But I think I thought to myself, I better check this out because my company is based on innovation and new technologies. So when I look very closely into this, there are papers from around the world, from universities in particular, which are reporting that conventional chemical treatments will not necessarily remove biofilms, particularly in a CIP system, but also on open plant cleaning. And the last point is that these bacteria and yeasts can actually communicate to each other, not the way that we communicate. They don't actually have a voice. They send out chemical messengers, and they can determine when the biofilm is full, if you like. It's reached its stage of maturation, and it's now time to move on. So on the next slide, we can see that more clearly. The top pictures of what we call planktonic bacteria, that's simply a scientific term to say that could be Lactobacillus brevis floating about in wort or floating around in cascade. And if those are left behind on a surface, in a tank, in a pipeline, or in a cask, easily eliminated with conventional chemistry. But that's not what reality is about within the brewing process. 99% of all bacterial cells and yeast cells will exist in a biofilm. If you look at the illustration below, we can see the life cycle of a biofilm. We can see the free swimming or planktonic organisms on the left-hand side, and what they're doing, they're looking for somewhere to land. They can actually perceive that environment and determine if there is enough nutrients on that beer pipeline or inside that fermenter, or certainly on the floor. And that's where we'll find most biofilms, because there's always going to be spillages on the floor. And once they detect that that surface has got sufficient nutrients of the right kind, they start a building block. They start to build a biofilm, which we can then see. And as we move to the right-hand side, what we've got in that biofilm is a three-dimensional consortium of different species of bacteria and yeast and molds, some of which won't affect the beer, but some of them most probably will. And when it gets to the end of the life cycle, like a volcanic eruption, the cap of the biofilm will open out, and bacteria will be projected into the atmosphere. And according to which way the wind is blowing in the brewery, they could land in adjacent fermenters, on fermenter surfaces, particularly valves, or in the packaging area. And the thing to remember about biofilms, these are not easily removed with conventional chemicals. That's just another illustration of what a biofilm looks like. So that could be the inside of a fermenter. It's a substratum, bit of an old-fashioned term, it means a surface. It could be a pipeline. And we can see that we've got a whole mishmash there of different microorganisms covered by that biofilm, which is protecting them from caustic soda, from nitric acid, from hypochlorite, and from peracetic acid. And we've actually got scientific documentation that none of those chemicals will effectively remove a biofilm without excess scrubbing or a CIP system with turbulent flow and for extended periods of time. So that's what a biofilm is, guys, and that's why they're so important, and that's why we need to find them if they're present, and most likely will be present, even if it's only on floors and drains within your brewery. And this is what this presentation is enabling you to understand. So this is a tool. It's based on a very simple test called the catalase test, and we just spray that onto a surface. It could be a floor drain, the outside of a fermenter, the inside of a bright beer tank. It could be a canning line or a bottling line. But there is a colour change, which I'll show you on a subsequent slide, but not this one. On this slide, we can see that the way that the product works is that biofilms will contain an enzyme called catalase, and the biodetector contains just three raw materials, three ingredients, which are food and beer safe. It contains a little bit of a surfactant to give it viscosity, so that if we spray that onto a smooth vertical stainless steel surface, it will stay there long enough to respond if a biofilm is present. It contains a little bit of a pink colorant to give us contrast, and the bit that does the work is a little bit of hydrogen peroxide, which you may be using in the brewery as a disinfectant anyway. So that's in the biodetector, a small amount. When the biodetector comes into contact with a biofilm containing catalase, the hydrogen peroxide in the biodetector produces micro bubbles of oxygen. And we'll look at that, and we'll look at some examples of that in a moment. But just looking at the right-hand side of this slide, these are the beer spoilage organisms which can be commonly found in brewery biofilms. These are the ones that we've just been looking at. And I make a statement at the bottom. And since 2016, every brewery, and I've been in literally hundreds of them, I found that they contain biofilms on floors in drains. And there may be biofilms there created by other bacteria such as Pseudomonas, which are not going to spoil your beer, but they can entrap beer spoilage organisms that will. So just a little bit about the product before we move on to something which is a little more exciting for you. It's fast acting, we spray it on, less than a minute you'll have a result. Doesn't stain, doesn't leave residues, easily rinsed or wiped off. No special equipment apart from a hand. And it's a complement of standard microbiological controls. In fact, it can help to optimize the cost of any swabbing programs that you may have in the brewery, because biodetector will reveal to you over a period of time, short period of time, you'll know where you're most likely to find infection, whereas before it was guesswork. So you may find that by using biodetector, it becomes cost neutral because we're actually reducing the swabbing program, which is not a cheap thing to do. So this is what a positive response looks like on the next slide. What we've got here are three pictures. On the left-hand side, an invisible biofilm has been cultivated on a stainless steel metal disc. The biodetector is applied, so we've got that translucent viscous liquid that is completely clear. And on this occasion, within 10 seconds, we've got the colour change, and we've got the microbubbles of oxygen, and then the hydrogen peroxide within the biodetector has detected the catalase, and this is called the catalase test, and it's a test that we've known about for about the last 100 years. So if we can move on to the next slide, because we've already covered that one. Common locations for brewery biofilms. I've tested for biofilms in many breweries now, and the red arrows point to where we're most likely to find them. And you notice that on the fermenters here, the outlet valve at the bottom, which is just a few centimeters off the floor, there's one there on the cone. There's one opposite the manway door. There's the manway door itself, and then we've got the fixtures on the top. Very often, CLAP will not effectively clean the inside of those valves. But what I'm concerned about is that biofilms growing on the floor are in very close proximity to each of those valves that we can see on that conical fermenter, and you'll notice that there are no blank caps on those valves. My advice to you is always to clean the outside of valves with a suitable detergent and spray with alcohol and put a clean and disinfected blank cap on. I know that when you've got a number of tanks in the brewery, it's time consuming, but it's giving that extra protection so that any biofilms which will undoubtedly be growing on the floor won't find their way into the inside of the fermenter through those valves, which although they're closed, they are open to the atmosphere and to any biofilms which are carried by feet or by hose pipes. As we hose the floor down, bits of biofilm can splash up and can actually reach to the top of a fermenter. It's surprising how far aerosols will travel generated by a high pressure hose. So here are some more examples of common locations for biofilms. Again, very often these can be blind spots for the CIP spray ball. It depends whether you've got a low pressure, high volume spray ball, which doesn't actually move. It's just a stainless steel ball with holes in. If you've got a high pressure, low volume spray device, you're more likely to get a more effective clean. but these are places to look for. So just take the top of the of those caps off and spray Biotector on, and we may find biofilms there which have to be removed, and we'll tell you how to do that in a short time. So again, that's just a close-up of the first slide that I showed you of where we're going to find biofilms. And on the next one, again, see how close that is to the floor. Any water being splashed around. We can see the floor is not completely clean. We can see residues of yeast to the left. Any beer spoilage organisms floating around in the atmosphere would actually see that as a perfect place to land and start to develop biofilms if they've not already done so. But you can see how short the distance is between that unprotected valve and the biofilms on the floor. Packaging now, whether it's cans or bottles, high speed, intricate parts, not a lot of components inside these machines can be cleaned with corrosive chemicals because they're made of materials, whether metallic or not metallic, but materials which are not resistant to corrosive chemicals. But this is commonplace that we'll find biofilms in these highly intricate machines. Whilst we're looking at this particular photograph, I would never recommend the use of corrosive chemicals for use on the outside of a machine such as this, and possibly not on the inside according to what the materials of construction turn out to be. But not only are enzymes good at removing biofilms, but they're also excellent products for use in CIP applications, particularly where we've got soft metals or plastics which are not resistant to caustic. That's what it looks like. So there's a drain. Now we know that drains are going to be dirty, even after we've cleaned them. We're not going to kill all the microorganisms there, but that is a substantial biofilm developing along that drain. That's the common place to find biofilms, and that's what we need to focus on as an initial approach when looking for biofilms within the brewing process on the cold side of the brew. Here's a beer transfer hose. Again, we can see the end of that is covered. If you can see the white deposit, that before we put the Biotector on was absolutely invisible. We couldn't see anything. But as you spray the Biotector on, it provides mass through microbubbles of oxygen. So we've now got a larger mass of aerated biofilm, and it now becomes visible. And that reaction took less than 5 seconds to manifest itself. So what we suspect is that we've got biofilms growing throughout the inner length of that beer transfer hose. Another common place are the gaskets on matway doors. In the old days, back in the 70s, I've been working at Basburton-on-Trent, and it was standard practice then to remove all gaskets before CIP and to stretch them over a wooden former and clean them by hand and put them back every time. And again, it's time consuming, but no CIP program is going to clean behind that rubber gasket. Very often, the rubber gaskets are perished. So they're not easy to clean. They're not easy to keep clean. If they're perished to any great extent, they should be replaced. But be aware, this is where biofilms can be introduced into that fine beer that you've taken time, trouble, and cost to produce. So we're going to find biofilms in every brewery. That's no reflection on a poor hygiene program. It's just that over the years, beer spoilage organisms, the way that food pathogens in the food industry, they've evolved genetically to produce these biofilms so that we can't get at them. So the fact that we find the biofilms is not an indication that you've got a bad hygiene program. It's simply that the bacteria have evolved to overcome the caustics and the acids and the hypos and the peracetic acids. So what do? There's two things we can do, as we see on the next slide. First thing is continue with what you're using, but look for biofilms and remove them. Bucket the brush, a green pad. The great thing about breweries is that we can predict with a reasonable amount of accuracy where we're going to find them, and we can provide a program for you to be able to do that within a very short space of time under your own steam. But what we do recommend where we find biofilms, particularly in the early days, is that we use an enzyme detergent that's been combined with surfactant technology. And the reason we say that is that, again, because of research that's been carried out by Camden BRI, we've had the privilege to work with them for 3 years on a biofilm project up until just before COVID shut down. We also work with the National Biofilm Innovation Centre at Southampton University. And there are papers literally from hundreds of universities across the globe that suggest that enzymes is the only effective solution to removing biofilms, because biofilms contain proteins, lipids, and carbohydrates. So the cocktail of enzymes that we produce contain protease for removing the proteins, amylase for removing the carbohydrates and lipids, lipase, sorry, for getting rid of the lipids. These components make the biofilm very, very difficult by conventional chemicals, but with enzyme technology, we can hydrolyze or solubilize, or if you like, dissolve them within just a few minutes. So the collaboration that we have now with Shane and Stuart at Whiteman Parish is to introduce their brewing customers and potential customers to the significance of biofilms. Remember at the beginning of this presentation, they're smaller organisms that can be protected in biofilms. So what we'd like to say to you is that if this is something that you feel would be worthwhile us taking a look at for you, and Shane and myself will come along, show you how to find the biofilms. We can then show you how we can remove them, and then we'll write a treatment program for you to use on an ongoing basis. The good news is we're not replacing what you're already doing. What you're already doing is 95% of the answer. The remaining 5% is that we're going to have biofilms. So we want to remove them. Having removed them, we want to prevent them from coming back. So what we're basically saying, guys, is that from time to time, augment your conventional hygiene program in the brewery with an enzyme step so that we can keep on top of it. And with the application of biotector on a regular basis, let's say every 2 or 3 weeks, we can tell when a biofilm is starting to come back, using an enzyme, zap it, and then go back to the previous chemical we'd be using before. So look forward to seeing you, hopefully, at some time in the future. And just to bring this in for a landing, I'll hand you back to Shane.
Yes. Thank you very much, everyone, for listening on that interesting presentation. I hope it's been a benefit to you. As I said to you before, if you would like to have if you've got any questions about what Paul's been saying to you, if it's of interest and you would like us to obviously come and attend your brewery, please obviously email me, call me, we can obviously organise something. Again, it's just something that is there to obviously implement alongside of what you're doing already. So whatever you're doing already at the moment, it's not going to affect that. It's just obviously to help remove these biofilms, which you may not be aware of. But yeah, any questions at all, please email me, call me, and I'll gladly speak to you and we can go from there. Thanks so much for your time. Have a good rest of the day. I'll speak to you soon. Thank you. Shane.